Hello explorers and welcome to another video. Today I'm going to talk a little bit about using native libraries in Android and how you can build native C code or C++ code and use them in your Android project. So in my case I had some C++ code that was a crypto library that GRC had built, or Steve at GRC has built, and I wanted to reuse that code in my Java implementation of my Android app here. And in order to build my native code, I needed to set up some things in my Gradle file for the application. So first off, down here we have a little path where the CMake should look for the CMake list file. And this is a configuration file for CMake, which assets it should build. So this path here, CMake list, will point out this text file that is in my app root. So not in the project root, but in the app root, if you have separate project and application. In my case, I have an app that is a module of my current project. So in my app folder, this module that is the application, there I have my CMake list. And then up here, I have some more variables, and these are not required for this example that I'm going to show, but I just wanted to inform you that you can actually give some extra arguments to the CMake build. For instance, I have one thing that I want to build, a really old library, crypto library that didn't compile with Clang, so I had to use GCC. So in here I can actually say that I want to use the Android tool chain of GCC, and I shouldn't do any testing on the build, and in this case these libraries doesn't have any testing, so that's why I put this off. And one of the libraries also need you to inform them that you have added a configuration header file, and these down here is just to tell which what kind of flags you want to send to your GCC in this case. So you can add some extra flags to your build process if required. So this is more against different projects, and these are not required for the process at hand. Next off, we look at the CMake list file, and in this you first tell it what's your minimal version. So if you install Android NDK at the moment, you will have a version of 3.4.1-ish, and that's the minimum version that I require. And this is recommended from the web page what version you should use. If you have an older version, you put that in. If you're looking at this in the future, then you can probably have a newer version. And then here we have two libraries. So I have a script and this library we're gonna look at today, and I call that GRC AESGCM, and it's a shared library, so all different processes can use it. And then I tell it which C files you should compile. So I have the GCC, which is one part of this crypto library, and AES is the other part. So AES is the crypto that can do AES 256, for instance, which is an encryption. And then GCM is the thing that you go over and actually verify that the encrypted bytes are correct, and you can also add some additional data that you haven't encrypted. So that's a kind of hashing algorithm over a bunch of data in order to see that you have the correct CDC or something at the end, so you actually have the correct checksum for this. And they call it tagging, so you can tag your encryption with a tag, and if you haven't got the same tag when you decrypt it, you know that something has changed in the data. So it's a verification tag. And then you have my little C file here where I put all the functions that I had to implement in order to have JNI. So we will look further into this file later on. Script, we will not go through that. And then you can also add where your includes are located. So these are the header files that you are needed to point out in order for the execution to actually find where to call into your code. So in this case, it's the same directory as we put our library in. And if we look at one of these header files here, so this is the header file for GSM, and in GCM header file is actually the one that Steve at GRC has implemented all the functions that you need to call. So this will in turn call the AES encryption. So you only need to implement some functions here. And then I have one function here that I haven't implemented yet. It's the GMC encrypt and tag. I have only implemented the decrypt so far. So if we look at my C file here, I have some function for auth and decrypt. I have some function for setting keys, and I have one function for initialize. And I also have a working context up here that I have added into this file. So we are going to implement this next part, the encryption. And in Java, this function looks very simple. It's just the input statement for a native function. And when you are using, or when you add this JNI file here, I have a static piece of code down here that actually loads my library. So I know that every time that the application starts, loads, and so on, this library will be loaded because of this static code here. So every time that the application starts, it will reload that library. And let's implement this function here. So we have a lot of different things here that can actually tell us a lot of information about the different parts here. And so we just need to implement a native function. So we start by doing it a public function, so we can use it. It should be static. You can use non-static functions, but in this case, I don't want to create an instance of this. I just want to use it once. I don't need any state in this class, so I will make my function static, and they should be native, and this one will return int, and I will give it the same name as it has in the other context. And in my C file, I have the actual context here, so that's not interesting. And the mode could be either GCM encrypt or decrypt, and I only want to do decryption, encryption. So I will hard code this in my actual function, so I can actually call this encrypt and tag, and just to make it even more specific what I'm doing here. And then we need an IV, which is a uchar pointer, and uchar is unsigned char, which in turn is byte, because byte is from 0 to 255. And I have one of these up here, so we have a byte array with a byte length, and these are the first things that we see down here as well. We have an IV and an IV len is two of the parameters here, so we can remove what we have implemented so far. Then we should have this add and add length, and we see here that we have the same parameters up here. And then we should have input, output, and the length, and those are the same as up here. And we should also have a tag and a tag length, and these are exactly the same as the function that I had before, which is handy. So it's easy to implement this, it's just copy paste. And now that I have this function here, we can see that it actually doesn't have anywhere where it's implemented. And if you stand on this in your Android Studio and press Alt Enter, you will get an information here that you can safely delete this function if you want. But that's not what I want to do. I want to implement this. And I figured out what was the problem. And this is a little bit interesting, actually, that as I understand it, it's hard for the build environment to figure out where to put the JNI implementation if you have multiple libraries loaded and if you build multiple libraries at one time. So my solution here was to actually have this CMake list file and comment out the script little library that I have implemented here as well. And when I did that, if we look at the function that we implemented here, GCM encrypt and tag, we have a red one instead. So it actually finds that this is not implemented yet and can't be used. And if I do an Alt Enter on that, I will get the option to create function Java org EA squirrel ini Gini grc1 as GCM encrypt and tag. So it's a very strange name, but it will create this, and it will also put a little to do here inside of this function, and it will throw it into the header file, which I'm not that fond of. I like to have them in my C file instead, so I will put the function in the C file. I will copy out the header information out of the header file and have a header there as well. So I have a header file and a C file. So now we have a bound, two-way bound function here that we can use that gets all the inputs here, the length and the additional data and so on. So now we need to actually run this function. So we will have some int result. So we will get a result back. We will run the GCM crypt and tag function. Let's see here. Yeah. And here we need to first off add our context, and that context I have here. So that's something that I initialized when I initialize the rest of the program. So this initialize function runs the GCM initialize, but it will also create my work context, and that's the context I will use in all of my encryptions and decryptions. So I give this my work context here, and then I will give it a lot of more data after that. It will get the IV and the IV length. So that's the next parameter. So let's see here. It needs a mode as well. Yes. So here we will give it the mode GCM underscore encrypt. And here we see that we don't have GCM encrypt because that was the value that the library created wanted us to use. So let's look into the header file, I guess, for the GCM and see, is it here? No, it's not. It's in the header file of AES. Here it is. So we need to actually have the header file of AES in our import here, so we will add that header file as well. So we will have that. So GCM, you can save it first. GCM encrypt, or is it AS encrypt? No. So what is that called? Oh, it's only called encrypt. Okay, let's use that there then. That's the next part. We look into the description here as well. So we first put in the context, the mode, then the IV length, and then the add length. So the add len, and you see up here that all these bytes that gets in is the system actually creates these fine little function that will transfer my byte array with the get byte array element and put it into a new function, that a new variable that is a jbyte, and that's very similar to the actual thing that you want to use. And some system wants you to actually cast this to an unsigned char. So some versions of the Android needs you to cast this value. And just to save time, I will copy the values that I had in the one above. So I get the same values here because it will have the same inputs except for the first part here. I will get a result, and this result is something that I want to return from this function, because that's something I will look for. So if the encryption fails, it will give me a hex code back that is hex 555555, and that's probably just so it's easier to distinguish from anything else. And then there is also another interesting function here called set byte array region that is also available on the environment. And this set byte array region will make it possible for me to set the data we are using in this function back to the actual region in my Java code, so I will get my bytes back to Java. And as we see in the input here, we will get a byte array of output underscore, and that byte array is not constant. It could be actually give or take values. So in this here, I see that I have an output that is an unsigned char, so I will get the output back. And as I do an encrypt, I will also get a tag back, so I will save that as a non-constant value, so I will get the tag back. So then I want to use the set byte array on the environment. I will set the output buffer from 0 to the length of the output. So this is the output length. So input and output has the same length, so we just send one length into this function, and then I will take this output unsigned char that I will get back, so this pointer over here, and write that back to Java. And then I want to do the same thing with the tag. So here we have the tag, and I want to write that back. There's probably something up here called a tag underscore that I want to write to, and I want to write it to the tag length. So that's the length of data I want to write back to the byte array in Java. So this is how you simply, if you just have one implementation, that you can actually generate most of the code that is required in order to go from Java into C. And if you have a well-structured and well-implemented C library that you want to use, they usually have already a JNI layer and usually an implementation in Java. But if you have pure C code and you want to use some functions in the C code, this could be a good way to actually generate some kind of binding sugar that you can actually bind these libraries together using JNI. And I think that the help that your Android Studio gives you in 3.0.1 is really interesting and makes this process very nice. I really like the way you can go from C to Java and back again, and how you can work with all these data. And if you're familiar with both languages, that is all, of course, helpful. And in my case here, if I'm done with my work, I will also uncomment this function here, and then I should be able to build again, and all the functionality that I want to use in this ASGCM will be implemented in Java as well, so I have native functions for everything. I hope that you found this little introduction into how to write JNI code was helpful if you are implementing your own Java code in your own application for Android, and you want to use some C libraries. And I hope that you learned something today. If you like this video, give it a like. Share it with your friends and colleagues, and if you haven't subscribed yet, please do that, and I really hope to see you in the next video.